Welcome to Enots Engineering, I'm Alan. In the workshop today we complete a tailstock die holder. We finish off making some of the last parts and the assembly. We also test it to see if it works. Now, will it work correctly, or does it smash into the end of the thread and damage the die? Let's go into the workshop to find out. This is what we made in last week's video, and today we start by cutting the external thread to match the internal thread, and then we'll cut 2 slots in the cones. I'm just cutting a 1mm pitch thread on the end of part 1, and this will fit into part 2. Now, I only have this control over the spindle movement because I fitted an inverter and a new motor. That cone screws on okay and goes right up to the face. I've just put a small undercut in here to relieve the thread. So we'll see if it will assemble now. We'll fit the 2 cones. I'll put that one on the other way. What I want is this one to screw in and lock up the 2 that are already on the shaft. Now that's locked, they've all locked up now. I've made a mandrel and I've assembled the body and the cones and held it on the mandrel. I just want to skim the outside to get the bar running true and give a better finish. The mandrel is made with a 5-thou taper from one end to the other end. If I just take the sharp edges off, and that was just held between centres on the mandrel. Now we'll take the 2 cones and mill a slot in the back. Placed a parallel strip underneath the part, held it with the aid of a V-block, and what I want to do is find the centre of the bore. I bring it in until it kicks to one side. There we go. I'll try it again. There we are. 0 there. Move to the other side. Half the Y distance. That gives you the size. Then move until that reads 0. And that puts your spindle in the centre of the Y-axis. that's the 2 cones finished. We now start making the adapter. If we face off the end of the bar and turn the OD down to size. Drill a clearance hole straight through and then bore a recess to fit the die. Turn the part around in the chuck and machine this end to hold a smaller die. Now all we need to do on this is drill and tap the holes to hold the grub screws. Now we move on to part 7, the guide bar, centre drill the end. And then tap the hole 3/8 BSF. Put it back in the chuck. And drill a hole 25/64 by 1.5 inch deep. That's the finished guide bar, which is 3/8 BSF. That's just drilled out. I've just put an M6 thread on the end of the bar that will be used as a handle. We'll start on the taper part now. In the end of this taper there's a 3/8 width thread, and I know that on my tailstock, when I put this in, it won't eject because it's too short. So I've just made a little 3/8 width screw, goes in there, extends it by about 1/4 inch, so when it goes in the tailstock you can wind the tailstock back and it will eject the taper. Remove my chuck. This is a number 3:2 Morse Taper sleeve. And now I can put the Morse Taper number 2 that came with the tailstock die ready for machining. The first job is to machine this 1 inch diameter on the end of the Morse Taper down to 3/4. Well, that's the Morse Taper finished. We have a 3/8 BSF thread on the end that fits the bar we machined earlier. Now I'm glad I made that little extension on the end, because you can see there the extension just sticks out into the slot, so now I can remove that with the drift. If you find that you have your taper stuck in the sleeve and there's no way you can use a drift to get it out because doesn't protrude into the slot, one way of removing it is just place a small nut into the end of the slot, put the drift through on top of the nut and use that to lever the Morse Taper out. So this is my 4-jaw chuck. On the back of that I've added my indexing ring, which is made from a car brake disc. There's a video on my channel to see how I made that. This arm is just bolted to 2 holes in the headstock. They're already drilled and tapped, so you just bolt this arm on, and then this has a plunger that goes into the hole, whichever hole you select. That locks the chuck. If you don't have a dividing head on your lathe or some method of dividing, you can use a protractor on the chuck jaw and set that to 45 degrees from the bed. Now I'm drilling a 5mm hole straight through. And tap the hole with an M6 tap. Couldn't get the chuck to grip the tap, so I'm just drilling the holes and I'll tap it by hand. While you have the lathe set up, drill all the holes and tap them in the other components. And next I'm making the torque arm actuator. I'm just cleaning up all the sides and mill the slot out in the centre of the block. And mill the gap for the selector fork. Drill the hole for the handle and clean up all the edges. And here's a finished torque actuator arm fitted to the die body. The drawing calls for a 1/4 inch hole through, but I've drilled and tapped it M6. And this is the finished tailstock die holder. Now let's see if it will work. So first of all we fit the guide bar in. And I've fitted a 6mm die in the end. Put that onto the guide bar. Bring that up to the workpiece. Now the idea is when I push this lever forward or backwards, it spreads out the cones, grips on the inner side, so that the barrel will not rotate the die. Now if I let the lever go, the barrel should revolve. So we start off by threading this piece of aluminium. So let's see how it goes. Push the lever forward and it starts to cut. Comes up to the face. Reverse the chuck. So that's revolving freely. Push the lever forward or backwards. It locks the die. That's going in, hits the face and revolves. Reverse it. Then as you pull the lever across, it will engage and remove the die. You can see my mistake there. I left the die on the bar cutting and it's taken the first few threads off. We'll now cut a thread on a piece of steel. It works very well and it stops the worry of your die hitting the face, and it's a nice project to make. Well, that's it for today. Hope that was interesting, hope it was useful, and we'll see you next time on Enots Engineering.